You know, there's a funny thing about sports. If you take any piece of equipment, it's kind of boring on its own. An American-style football, just a piece of leather, but put it in the hands of a running back and it's exciting. A skateboard just looks like something to trip over to me, but in the hands of a pro, it's amazing to watch what they can do. In other nuggets, we've had the chance to talk about logical switch tables, the VTEP table, ARP table, and MAC table, but in this nugget, I'd like to show you those tables in action. Because when it comes to troubleshooting NSX, when things go wrong with VXLANs, we want to have a deep understanding of how information is relayed and used in our NSX environment. Well, my friend, feel free to join me. We're over here on HOL 1903 in the VMware Hands-On Labs. We're going to fire up Google Chrome in order to manipulate the VMs that we need. So we'll log on as administrator at vsphere.local with the lab password. Here in the vSphere web client, we're going to be working with a couple of VMs. So let's go ahead and navigate to our VMs mode and expand region A. We're going to be looking at Web 3 and Web 4. And I'd actually just like to shut those down. Let's make sure that they're in a cold state to begin with. So we'll select Web 3, give it a shutdown. Yes, we're sure. And we'll go to Web 4. We'll start the shutdown on that. Yep, we're sure about that one. That works. And then let's go build a new logical switch. We'll head up to the home icon, down to networking and security, NSX Central. And from there, we're going to go over to logical switches on the left-hand side. We'll bravely click the big green plus for a new logical switch. And we're going to call this table test and leave it with the defaults and click OK. Now, in order to observe our logical switch tables, VTEP, MAC, and ARP, we need to dig into the soft underbelly, and we can do that by looking at it through the CLI. So let's pop up our PuTTY. And in PuTTY, we've already got a pointer to NSX Manager 01a.corp.local. So we'll double click that. And we're going to log on with the admin password of VMware1! So for the exercises that we're going to do right now, there's a bunch of commands that have the same prefix, which will make this a little bit easier. We're going to be running the command show space logical-switch controller master VNI, there's that VNI reference, in this case the number 5008, and then there's going to be various different extensions on that. So up arrow will be our friend, because if we want to look at different aspects of this particular VNI referencing off of the master controller, then we can do so. So let's look at our three tables to begin with. If we type in VTEP, we simply have a reference to the master controller. If we type in MAC, we just have a reference to the master controller. If we type in ARP, we just have a reference to the master controller. So our three tables are empty with regard to 5008. We can also up arrow and test connection. Wow, that's empty too. These tables are empty because there's no need to populate them because nothing is yet using this particular logical switch. So let's change things up a little bit. Let's go back to our web client. We'll go to Virtual Wire 10 5008 table test. We'll right click on it and choose Add VM. And we're going to add the VMs of Web 3 and Web 4. Once those are selected, then we can throw them on the right hand side, click Next, change the adapters from being plugged into a distributed switch into being plugged into this logical switch, then we'll click Next, and we'll click Finish. Now on the right hand side, we can see under Connected VMs, the number 2, so we've got two hosts running two VMs that are plugged into logical switch table test number 5008. Now having associated the vNICs with the logical switch, how does that affect our tables? Well, let's look. Do we have any new connections? Nope, no connections. If we go up and take a look and replace that with VTEP, empty. How about MAC? Empty. And how about ARP? All empty all the time. So associating a VM with a logical switch does not populate any of the tables, does not start any action with regard to NSX. What does? A live VM. So when we start having a powered on VM, locally powered on or vMotioned to a particular host, so let's see what happens when we power on our VMs. We'll head over to VMs and templates, and let's simply power on Web3 corp.local. Right click, power, and choose power on. And we can see it's in the process of booting up. Let's check our tables. Let's take a look at the connection table. Ooh, things got interesting. So now, host at the IP address of 192.168.110.52 running at this port has the host ID of 9. This is an internal reference mechanism for each of the hosts. So suddenly we have a connection to this controller for this particular VNI. So we would expect to also see a VTEP reference. Let's take a look. We'll up arrow and change that to VTEP. When we look at the VTEP table, we also see the IP address of the host, but now we're seeing 192.168.30.52. as opposed to 192.168.110.52. Why the discrepancy? Why are there two IP addresses here? Well, remember that the connection reference is identifying that there's an ESXi host that is now in communication with the control cluster node. In this case, it's 192.168.110.31, being connected to by the ESXi host at 110.52. So this is in reference to the control plane. Because we're using unicast as our replication method, anytime there's an update to the VTEP, MAC, or ARP table, the host has the responsibility to tell the control cluster, and then the control cluster can inform the other hosts that are also participating in that logical switch. That second IP address is in reference to the same ESXi host, but now we're talking about how ESXi is going to have a tunnel endpoint so that it can communicate with other potential ESXi hosts and their tunnel endpoints when communicating on behalf of VNI 5008 for some potential clients. So in other words, this is the data plane IP address. This is where we're actually talking about the transport of VM to VM communication. So our VTEP table has been populated, currently with just a single IP address. Let's keep checking out our tables. We'll up arrow and let's take a look at the MAC table. So for VNI 5008, we see a reference to a MAC address. Now whose MAC address is this? This is Web3A's MAC address. So that particular network card from Web3A powered on, and it's being referenced. If you're ever looking for that MAC address, it's available by tunneling to this particular VTEP IP address, 130.52, which of course is referenced here in the VTEP table, and we have the reference to it as a unique host, connection ID 9, the same one we see here and here. So just keeping everything consistent. Let's up arrow again and let's take a look at our ARP table. And the ARP table has information in it as well. So assuming that we have IP configuration on the VM that's connected to the logical switch, then as that VM communicates on the network, self-identifying itself, then this ARP table is populated so that ARP resolution can be done by the switch instead of having to populate the entire network. So the ARP table is all about matching up these two pieces of information, the IP address to the MAC address. But we also do have the connection ID to know where that information came from. The connection ID is identifying the source of information. Does the ARP table provide any way to connect to that specific IP address? It actually doesn't, because to connect to that IP address, we would need to forward the traffic to a VTEP. But the IP information can be used to populate the MAC address. Once that information goes back to the VM and it sends out a packet addressed to a specific MAC address, then the MAC reference here can go to the VTEP IP. The VTEP IP is used to reference that endpoint and actually allow that to communicate with the destination. Let's go ahead and start up Web 4 and populate this a little bit more. We'll go to power on for Web 4A, and let's take a look at our tables once again. What would you expect to see at the connection level? Since Web 4 runs on a different ESXi host, I'd expect to see a new connection here added to our existing one. And sure enough, we have 53 and 52, connection ID 7 and 9. And you'll notice that the source ports are dynamic rather than being a static source port. Let's take a look at the VTEP tables. Since we have multiple tunnel endpoints, these two destinations are listed here. So 52 and 53, but these are on the 130 next. So we have two connections, two sources of information that are being used to populate these tables. We have two tunnel endpoints that are being used to carry the data plane traffic. And these MAC addresses that we see on the right-hand side are associated with connecting to those tunnel endpoints. Let's up arrow. What do we have in the way of MAC addresses, Johnny? VNI 5008 has two virtual NICs. We can see the MAC addresses of those virtual NICs and the VTEP that is going to be used to host those. So these are on two different hosts we can see. And the source of the information actually came from those two different hosts, which is not surprising at all. And let's take a look at the ARP table. So 40.11 and 40.12 are both able to now be resolved for those particular clients. Let's just quickly validate our intra-switch communication. And here in the background, we can see web4a corp.local. If we want to click on that and actually click on the icon to log into that system, we can do so. It'll fire up a new tab. We can log on with the default login of root and put in the password of VMware1! And let's type in ping web-03a. Oh, you know what? We don't have resolution set up for that. So let's just ping 172.16.40.11 and press enter. And so we see successful resolution, but what did that involve? And we've seen that ESX A and B, as we're referring to them now, are connected to the control cluster node of 192.168.110.31 from their IP addresses of 110.52 and 53, but that they have tunnel endpoints that are able to connect to each other on the physical network at the IP addresses of 130.52 and 130.53. So when Web4 started that ping that we see right here, we had a reference to the IP address of 172.16.40.11. Before the ping can start, an ARP is necessary to get the destination MAC address. So to fulfill this on a logical switch, ESXi-B checked its local ARP table to see if it had resolution, and it did. 172.16.40.11 was already in that table. So therefore, ESXi-B was able to immediately respond back to Web4, hey, here is the MAC address that you're looking for. So now that the ARP is completed, the ping can continue addressing that virtual MAC address that's associated with 40.11. So now that data packet goes into ESXi-B. ESXi-B now says, okay, this message on 5008 is addressed to a particular MAC address. Do I know where that is? Yes, that particular address is associated with the VTEP that's at 130.52. So ESXi-B takes that initial ping message and wraps it inside of a VXLAN message that is associated with 130.52 and sends it over the transport network. ESXi receives it, identifies, oh, this is a message for 5008 for a particular MAC address that's on there. I have that logical switch. I can certainly forward that on. So I will de-encapsulate that message, leaving it with just the original ping, and forward it on through the switch to Web3. Now Web3 needs to respond back to that ping, right? That's what we're actually seeing are the replies. Web3 needs the MAC address of 172.16.40.12, so it will ARP for it, and ESXi-A can supply that answer straight out of its ARP table. Then Web3 will send the message forward, and that information will be populated out of the MAC table, which resolves the information of the VTEP table so that we can send the ping response back through the physical transport network encapsulated with VXLAN referencing of 5008, which gets to ESXi-B, which de-encapsulates it, which sends it back to Web4. If we had another host, we'll call it ESXi, and it's not participating in that particular switch, it's only in 5009, then it doesn't maintain a VTEP table for 5008. It only maintains it for 5009, and only for 5009 if there's actually a live VM that's using it. Now let's run one more test. We're going to close our console to Web4. We're going to right click on Web4a, and we're going to go to migrate. We're going to say that we want to migrate the compute resource only. We'll go ahead and select ESX2 and then click next. We're going to leave it on that same network, our virtual wire 10, the table test network, perfect. Default, next, finish. All right, so we're vMotioning Web4 from ESX3, where it's currently located, to ESX2. All right, it says it's now on ESX2. How will that affect the tables? Well, let's take a look. If we go back to PuTTY, take a look at our connections, we can see we're down to one connection. If we take a look at the VTEP table, sure enough, we only need one VTEP entry. So our connection VTEP tables are indicating there's only one host that is participating in the logical switch that is live hosting a VM that needs to receive any of that traffic. If we take a look at the MAC and ARP tables, though, will they be any different? The core content is the same in terms of what MAC address a particular VM has, but now both devices are registering off the same VTEP ID coming from the same connection. And if we take a look at the ARP tables, again, we have the same resolutions, but now coming from one common source. They're both associated with connection ID 9. From the perspective of the client, does it matter? If we open up Web4 and up arrow, and now perform the same ping? Well, no, it's really no different from the client perspective. That's the beauty of the VXLAN. It is transparent to the client and it's transparent to the physical network. The virtualization infrastructure itself handles the heavy lifting of tracking down the networking elements and making sure that the VMs can talk to one another. My friend, by going through this nugget together, you've had the opportunity to see what populates and depopulates the content of our VTEP, MAC, and ARP tables, and see our connection IDs and ports as well. If for some reason this information is inaccurate or not able to be communicated correctly, then VXLAN communication, the support of the logical switch, will fail. And that's where our troubleshooting will begin. I hope this has been informative for you, and I'd like to thank you for viewing.